Hello all, welcome back to yet another problem. Let us solve today's lead code daily challenge. The problem is longest common subsequence, and this is a medium problem and this is a standard interview problem. Let us solve them. Given two strings text1 and text2, return the length of their longest common subsequence. If there is no common subsequence, return 0. A subsequence of a string is a new string generated from the original string with some characters can be generated without changing the relative order of the remaining characters. For example, if this is the ACE is a subsequence of this A, B, C, D, E. Why so? Yeah, we can delete this B and D. Therefore, we get a sequence ACE, which is a subsequence of this A, B, C, D, E. Common subsequence of two strings is a subsequence that is common to both strings. So we have to find the longest common subsequence for this problem. So that is the problem description. Now let us analyze the examples. So given the text 1 is A, B, C, D, E and text 2 is nothing but A, C, E. So what is the common subsequence that I can get? You can say that there is a common subsequence A of length 1 and there is a common subsequence of AC of length 2 and there is a common subsequence of A and E of length 2 and there is a common subsequence of ACE itself for both the two strings. So therefore we can form a 3 length that is the maximum maximum length that we can form with these two strings, which is a common subsequence. So the for example 1 the output is 3. For the example 2, the ABC and this ABC, this is already equal, so we can just return 3. And for the example 3, the first word is ABC and the second word is DEF. As you can see, there is no common characters. If there is at least one character, we can say the output is 1, but there is no common character, but there is so that we do not have any common subsequence, so we return 0. So how can we solve this problem? So we want to maximize our output. So obviously we can think of exploring all possibilities or all solutions. So if this case occurs itself, we can tend to think of an approach using recursion. So how can we do this recursion? We want to find, our ultimate goal is to find the common subsequence. So our common subsequence of two strings. So what are the parameters that I need to have in this function is nothing but I and j, which is going to be the index for the both the strings. Solve of I and j. Hope you understand. So when can we have a common character? If there is a common character, then our output is going to increase by 1 in our answer. So what I will be doing is, if my s of I is going if my t1 of I is equal to t2 of j, then I can have an output which is nothing but return 1 plus. I can take this common character so that I have one step and I will go to the next recursive call with I plus 1 and j plus 1 called. But what if I do I do not have a common character? If I am not having a common character, I have two options. Either I can move I or I can move j. So those are the two options. So option 1 will be move solve I plus 1 and j, and my option 2 will be solve of I and j plus 1. So this will be my option and I can just return maximum of both the options. So by this I am exploring all the possibilities and I can form the longest common subsequence. So this is recursion. Obviously the solution time complexity will be exponential for each character. We will be tend to exploring be exploring two options. So it will be 2 power n into m. So what we can do is we can obviously reduce this by memoization. Before that, what does this solve of ij represents is nothing but I will be calling this main function from n minus 1 and m minus 1. So consider we are going to go in backwards. So we will say I minus 1 and j minus 1, and here we can say I and minus 1 and j minus 1. So what does that indicates is nothing but dp solve of n minus 1 I minus m minus 1 is nothing but when we memorize it, it is going to be dp of ij, right? So dp of ij is nothing but the longest common subsequence that can be formed dp of ij is going to represent the longest common subsequence that is formed from 0 to I and 0 to j. So this is what this dp states represents. So hope you understand those recurrence relation and the recursion. Let us try to code the approach and analyze the problem. So now what we can do is we can first take the length int m equals to text 1 dot size, int n equal to text 2 dot size, and I'm going to call this return solve function using m minus 1, m minus 1, n minus 1, and text 1, and text 2. So these are the parameters that I'm passing. I can have a private method which is going to return, instead of saying this as solve, we can get the longest max length. This is going to return me the max length of this common subsequence. So max length function is called by int I, int j, and string text. Let us say it as s1 and string ampersand s2. So let us analyze the base case. What will be my base case? So I will give two examples. If there is a string a and if there is a string ab, so we are saying that a and a are equal. So I will be adding it to my answer and I will be moving I and j. So as you can see, this I has reached the boundary and j has not reached the boundary. So what does that mean is if my I or j has reached the boundary, I can end that process. So I can return 0. If my I is equal to s1 dot size, or if my j is equal to s2 dot size, then I have reached one of the boundaries, so I can just return 0. I cannot find any longest common subsequence that can be formed with both the strings. That is what it represents, right? So this is our base case. This is our base case. So next what we can do is we can have a check to find the common character. This is going to be our common character. Then I can increase by one step. So if my s1 of I is equals to s2 of j, then I can return 1 plus the max length of I plus 1, j plus 1, s1, s2. So this will be my current condition. Else there will be two possibilities. There will be two options. So let us say in option 1. Option 1 is nothing but since these both characters are not equal in s1 and s2, either I can leave this character from s1 and I can search from the next character, which is nothing but max length of I plus 1, j, s1 and s2. And option 2 will be I will be leaving the character from the second string, and I will be moving and searching for the maximum length. So at the end of the day, I'm going to return the maximum of both these options. So this will be my recursive solution. So let us try to run the code. Okay, it gets wrong answer. Let us analyze what happens. Sorry, I have missed here because I'm coming from reverse direction. Reverse direction in the sense I'm coming from backside. N to 0 and M to 0. So we have to move backwards. I minus 1 and J minus 1. Here as well I minus 1 and J minus 1. So now we can try to run our code. Yeah, the base condition is actually wrong. It should be I lesser than 0 and j is lesser than 0. Since I am coming from backwards, it is going to be like this, right? Now let us run the code. It gets accepted. So this will be my recursion. So now let us memorize the solution to get accepted, else we will get TLE. So what will be our changing parameters in our recursive solution? The parameters that are 2, I and j. So we can have a two-dimensional dp, which is the vector int dp of size m and a vector of int size n, which is initialized with -1. And I can pass this dp here. I can pass the dp as well, dp and dp, and here dp of ij is memoized here, and after the base condition we want to include that condition as well. If this problem is already solved, dp of ij is not equals to -1, then that is a sub problem which is previously solved, so we can just return dp of I and j. Hope it makes clear. So vector of int ampersand dp. Yeah, that's it. Now let us try to run our code. It should get accepted. Superb, it gets accepted. So this will be the dp solution using memoization. So that's it for this problem. So hope you like the solution, and yeah, let us see in tomorrow's LeetCode daily challenge. Until then, bye.